Hello everyone, welcome to Dr. Ravi's Academy. In today's class, you will be understanding what is meant by kinematic chain and the types of constrained motions. Let us understand what is meant by kinematic chain and define kinematic chain. Let us consider the combination of number of kinematic pairs joined in such a way that the first requirement is last link joined with first link. The last link is joined with the first link, and the second requirement is must have constrained motion. These are the two requirements in order to call a chain as a kinematic chain. Now let us verify the chain whether it is a kinematic chain or not. I am considering three links joined by pin joints 1, 2, 3. And in order to verify kinematic chain, you have an equation. Let us look at this. L is equals to 2p minus 4. So by means of this equation, you can verify whether the chain is a kinematic chain or not. In this, number of links are 3. So let us calculate RHS, right hand side, that is 2p minus 4. In this you have 3 pairs, that is A, B and C, 3 kinematic pairs. 2 into 3 minus 4, so that is 6 minus 4, 2. So you have RHS is 2 and left hand side, as you know, that number of links are 3. So here LHS is not equal to RHS. So this particular chain is not a kinematic chain. Likewise, let us consider a 4 links connected by means of 1, 2, 3 turning pairs and call it as A, B, C and D. In this, you can see that LHS is equals to, you are going to get, it is number of links are 4 and RHS you are going to get, it is 2 into P, number of pairs are 4, that is 8 minus 4 and 4, both are equal, and a 4 bar chain is a kinematic chain. Like that you can verify a 5 link also. Let us consider a 5 link, that is 1, 2, 3, 4 and 5. So in this you can see the number of links are 5 and RHS, you can calculate RHS is equals to, it is 2p, 2 into number of pairs also, it is 5 minus, that is 4. So 10 minus 4, it is 6, whereas LHS is 5. So LHS is not equal to RHS. Left hand side is not equal to right hand side, and this is not a kinematic chain. Among 3, only a 4 link kinematic chain or this particular chain is called kinematic chain. So this particular equation, to check whether it's a kinematic chain or not, here it is going to conduct, you can see that the first condition is satisfied in all the cases. The last link is joined with the first link. In all the cases it is satisfied, whereas the constrained motion is only possible with 4 links, so that you can call it as a kinematic chain. Now let us understand the types of constrained motions. You have 3 types of constrained motions. First one is a completely constrained motion. Let us observe a circular shaft rotating with the 2 end collars, and you can see that you have a one type of motion, that is rotary motion. The shaft is rotating, only rotation you have, so it is completely constrained. The motion is only one direction, only in one direction. So whereas let us look at second one, that is partially, which is also known as successfully constrained motion. You have one side collar, the other side is free. So if you remove this load P, what happens? It rotates as well as it can slide along the axis. So that sliding you are arresting by means of external force, and that is the reason that particular motion is called partially or successfully constrained motion. And the third type, let us see incompletely constrained motion. And this particular shaft, circular shaft, you have removed both sides two collars. So that means this particular shaft rotates as well as it can slide along the axis. The direction of the motion is not in one direction, it's more than one directions. You have rotary motion as well as sliding motion. That is the reason it's called incompletely constrained motion. So as far as machine design is concerned, you need to have first two conditions are essential. Either it may be completely constrained or it may be partially or successfully constrained in order to fulfill the requirement of the machine design subject. Thank you.